This is IAT355 Visual Analytics Lecture 2.4, when we're talking today about data wrangling and metadata. So data wrangling is the process of manually converting or mapping data from one raw form to another. And the purpose for doing this is for more convenient consumption of the data with the help of semi-automated tools. And typically what is meant by data wrangling is the management of data, getting it all together, and defining the complete schema or schemae, multiple schemas. Now, one of the things to bear in mind is that data wrangling is actually a kind of a difficult suite of tasks to engage in. When you deal with complex data, it is hard to understand the various complexities when you start. And part of the job of data wrangling isn't just the details of manipulating one data type and fitting it into that field. It's understanding the relationship of the various data fields, what a particular table might mean, why this table puts certain variables together, and transforming that into a form that can be used for analytical tasks that don't directly fit with the original table or tables that you've got. Something that's very important to bear in mind is that it often takes a significant proportion of the time of any analytics job. And one of the things I was going to put on this slide as I was putting it together is it's not just you who's having this problem. That is to say, when you start to deal with real data, often folks find it difficult to deal with the arbitrary complexity of the data formulation, the way the tables are organized. And part of the job there is about learning to put yourself in the mind of the folks who constructed the data set, and that can be very difficult. One of the things that often makes that difficult is that sometimes data is not necessarily well documented. It's not as organized with the idea in mind that some other party other than the organization who put that data together is going to look at it and understand it. When data is presented on the World Wide Web or is being consumed in a semi-automatic manner or is the result of a consortium of people working together, data wrangling is a little bit easier because the job of explaining how the data is organized needs to be done at the start of making it publicly available. But that's not always the case. Okay. So let's give a little example of data wrangling. This is really just a tiny example. And what we're going to talk about in experiment data is that you have a number of variables or dimensions. In experiments, typically variables are classified as dependent. Typically, those are variables of primary interest. So, for example, in a hypertensive drug trial, it might be blood pressure that you care about. The purpose of the drug is to lower blood pressure, so to reduce the risk of stroke, and so therefore it's a dependent variable. Does the drug reduce blood pressure in people who take the drug? And it's what we want to know about in the experiment. Independent variables, or predictor variables, shown in the center here, are called sometimes a factor when controlled by an experimenter. So, for example, a factor that might be present is the sex of the person who's taking the drug. It is independent and can be selected by the experimenter. We're going to have a group of men who are age 50 to 60 who are going to take this drug, and another group of women who are age 50 to 60 who are going to take this drug, and the independent variable is the sex of the individuals taking the drug. The third variable are random variables, things that are not controlled by the experimenter, but are just simply, in the experimental sense, what is true about the individuals coming in the door. So, for example, a random variable might be whether the person smokes or not, or whether they have heart disease or arthritis, or any other kinds of things that might affect the outcome of an experiment that is measuring the effectiveness of a drug. These are all experimental terms, and it might be the case that you have to figure out how they apply to analysis of experimental data that comes out of the result of doing a trial like this. So you might end up in this trial coming up with a table of observations. What we're showing here is the month when the observation was taken, and a number indicating the blood pressure of the control group in March. And here we have the number for April, May, June, July. And similarly, we get blood pressure numbers for the placebo, that is to say, sugar pills, a pill that does nothing. The control is no drug at all. 300 milligrams is the quantity of the experimental drug at a lower dosage, and 450 milligrams is the higher dosage drug. And you get a measure of blood pressure for each one of those months there. So 4 treatments, 5 months shown in this table. Now, and this right here is, this single row in the table is a data case, and that's the data case for March. And it might be the case that what you're really interested in doing is organizing your data such that that row is the primary thing that you want to deal with. Another commonality, of course, is that this column, for example, is the results for the 300 milligram dosage for each of those months. You might therefore wish, if you're doing analysis and wanting to make a comparison between each of the interventions in the trial of the control group, the placebo group, the 300 milligram group, the 450 milligram group, organize those in a column and get an independent measure during the month of March for each of those 4 groups. So this is a very, very trivial little refactoring, but it's an example of the kind of thing you might need to do if you're data wrangling. So data comes in many different forms. This cloud of application icons is intended to get that point across, and typically it's not the way you want it. The kinds of concerns that you have to deal with in the details of data wrangling are things like formats and types, and getting the files that you want that represent the information or contain the information you're looking for. And sometimes the information you're looking for might be stored in a relational database and might need to be generated as a result of joining or doing database operations to get a collected table that is distributed amongst various tables within the database. And you might want to also deal with the structure and relations that are present in the data collection and figure out what the purpose on the analytical aggregation methods that are used in the data storage that you've got to be able to analyze. And it's not just formats. One of the things that I'm intending to get across with this suite of images here is that sometimes data is coming from a field that you're not necessarily familiar with, and the field, the group of folks who work, say, in geographic information systems, they have their own language to express themselves, their own way of organizing their data. And if you're getting data from a source like this and data from a source like this, which this might be biological data, you need to be able to translate practically between the languages spoken by the 2 groups of practitioners, so that you can also deal with information coming from data generated by those practitioners. And so what that means is that sometimes when you're doing data wrangling, you're having to do data integration. And that is the case when data comes from several applications, because each application might have a different aspect of the data, and what you're trying to do is put all that data together to be able to analyze it as a whole. And when you're doing integration, these kinds of problems come into play. Things like file layout, encoding, dealing with field names, systems, schema, and to some degree what's called data heterogeneity are big issues. Data heterogeneity really means that one application stores the kind of information that you're looking at in one method using one suite of names, and another application that kind of does the same thing stores its information with a different kind of naming scheme and a different kind of organizational idea. Think of the way various animation tools store their data. So, for example, Maya stores its data and names things in one way, Cinema 4D organizes things in another way, and Blender organizes its information in yet another way. It's the same kind of problem when there are multiple different types of tools that are intended to do roughly the same kind of job. You're going to have to deal with the differences from application to application. And when you're dealing with multiple data sources, you typically have to deal with getting an understanding of each of the way in which the data is organized for each of those data sources, and coming up with a means by which you can get the data to merge the data from all those data sources in a manner such that it actually makes sense, that data ends up in the same fields that actually means the same thing. So commonly what that means is the stuff that's indicated in this red box. The first thing you have to do is come up with a complete schema that it deals with all of the different data organization methods for each of the applications or fields that you're getting things from. Decide on a unique identifier for each data item, some kind of index or ID. Extract information from each of the data sources and then merge them together. That sounds simple, but the key job of extracting and merging is to make sure that the information coming from multiple sources are ending up in the right spot together. The fifth step that you might then need to do is to transform that data that it's been merged together into a form that's suitable for being used in a visualization system, and then go ahead and load it up. So the short version of this slide is essentially that data integration requires a significant amount of work, and this is the kind of the strong version of data wrangling, is dealing with multiple sources of this nature. Some things that you might need to deal with as you're doing a task like this is to deal with the metadata, which is descriptive information about the data. Now, the simple version of metadata, we haven't shown this table before, but here's a table in which each data case is shown in columns, and each row is an individual variable. I've just transposed rows and columns in this thing. This is an identifier row. This might be the age. This is the time that's these individuals joined, say, SFU, and this last row here is the grade point average of each of those individuals: Mary, Tom, and Louise. Sometimes the metadata is very simple, like this is just a name for what the field is and a type to indicate what the valid range of the data is, and whether it's numeric data or ordinal or nominal or whatever it is. Clearly, Mary, Tom, and Louise are nominal data fields, data values. However, sometimes the metadata is a little bit more complex for times when the table itself isn't enough. For example, this 2.3 is highlighted in red because we might have, as a metadata information, a rule that says if the term is greater than or equal to 22, and that's the term that Tom is in up here, the GPA is only allowed to be above 3. Otherwise, Tom's in trouble, or there's some kind of validity problem with Tom's data. Missing values, uncertainty, or importance are all examples of metadata, things that are about the data but are not being analyzed directly, but are being used to inform the analysis. So, for example, if you have missing information, what should you do with the fact that there's an item with a value missing? If when you're talking about grade point here, you're pretty certain on what the outcome is, but maybe if you're evaluating a course that's in progress, what do you do with the fact that the grades are not yet ready, but you still want to compute a GPA? We all know what the rules are in SFU, but that would be good to know if you're looking at another university's rules for computing grade point. So those are examples of metadata that you might need to deal with when you're doing data wrangling. Okay, so that's just a quick kind of flavor of the last thing in this data lecture, which is about data wrangling and metadata, the kinds of difficulties that one confronts when managing collections of data, and just very, very brief sketches of approaches to take in dealing with that kind of information.